Domain and range of a function. Domain and range of a function. What is domain and range? If we have a function f of x equal to y, or I'll switch that around, y is equal to f of x. Very simply, that is the domain. This is your range of y values. Range of y values. X is the dependent variable. No, y is the dependent variable. X is the independent variable. And then independently brings in values that y depends on. So the domain is the range of x values, and the range is the range of y values. So how do you find the range and domain of a function? Most students, or students I've encountered, had problems with not the sometimes with the domain, but mainly with the range. And what you simply need to do, because the range is not obvious all the time, is that you really need to actually draw out the function, graph the function, and see how it increases horizontally, not horizontally, vertically upward and vertically downward. So to see example of that, we need to do an example. So just simple example, suppose we had f of x, which you'll definitely run into something like this, f of x equal to x minus 1. Okay, so x minus 1, thinking about the values of x minus 1 as far as domain, well, we know the square root of this x minus 1 has to be real values because we're working in real space. Anything like we say we put like a negative x equal to negative 2, that would make a square root of negative 3, which makes that I times the square root of 3, which is a complex value. Can't graph a complex value. So we know that the square root has to be greater than or equal to 0. So we conclude that x minus 1 has to be greater than or equal to 0. Solve the inequality, and we got x greater than or equal to 1. That is our domain. Now, we know the range. The range has to be, look at this square root again. The range here, if you can't get a negative, you can't, look at the square root, you can't get a negative no matter square root. However, you can get a 0 out of square root. Square root of 0 is 0. Square root of 4 is 2. So therefore, the range has to be at least 0 and or greater. So what would be the range? It would be a 0. Let's say f of x. Y would have to be, it's going to be y 0 less than y, or y greater than, never mind this, y greater than equal to 0. Or in interval notation, I would say 0 from 0 to infinity, but this is included, square bracket. I can see this from experience, but if you don't have experience, what you need to do is graph it. So I'm gonna sketch the graph here. So if you sketch the graph, let's see, this is 1, this is 2, this is try to make things even out. I already know the graph, this graph. So this is 1. So this graph study increases like this. This is a rough sketch of the graph. It's increasing. It's gonna get higher than 2, way higher than 2. This is this graph here. Now you can see the domain is from 1. So x is greater than equal 1. So 1's right here. As it goes to infinity horizontally. Horizontally. You can see that. But y's have to be greater than equal to 0. If we look up and down, you see this graph doesn't go below the x-axis. It doesn't go to the negative y. So here is a negative 1. That's an ugly negative 1. Negative 2. But it doesn't, you don't see anything down here. You see it up here. This graph study increases. It doesn't look like it, but it's going to go to infinity. It's not going horizontally, it's steady increase. It's going to get a very slow increase, but it's going to increase. So it increases to infinity. And this will be your range. That's your range. That is your range. From 0, including 0, all the way to infinity, or y greater than equal to 0. That is your range. So if you can see that it's better probably to graph it if you can't, don't have experience. Just graph it and look at how does it behave up vertically and down vertically, and you can see by eye view what the range is. So let me erase this and do another one, or do a clear. Let me do a clear. And let's do another one. How about g of x is equal to square root of 4 minus x squared? What's the domain? Domain. Well, we know that 4 minus x squared has to be greater than equal to 0. So 2, x has to equal to 2, x can equal to 2 or plus or minus 2. Or x has to equal to 4, it has to be greater than equal to 4. Or less than equal to 4. X is less than equal to 4. So in this case, I'm sitting here looking, it's like, well, in this case, the domain is not really easy to look at. It really is not. You can't see it. You really can't see it. I mean, technically, theoretically, you can make g of x equal y, and we go 4 minus x squared. Square root, take the square of both sides. You got y squared, 4 minus x squared. This is x squared. We solve it, x squared. X squared minus y squared plus, let's see, we bring that x squared over. So x squared y squared equals to 4. So this is basically the equation of a circle. Basically, equation of a circle. But that doesn't help the situation. If you look at domain, you can see that it has to be greater than or equal to 2. If you put a, let's see, if we put 5 in there, it'll be 4 minus 25, and that wouldn't work. So just by looking 2 and negative 2, 2 and negative 2. So my domain would be a negative 2, 2. And what would be the range? What would be the range? So this is one that you would almost do better, even with the domain, to actually draw the solution. Try to find it this way. So I'm just writing this because I already know the graph here. So the graph looks like this. This is a rough sketch of the graph. This is g of x equal to 4 minus x squared. The domain is in notation is of course from negative 2, including that to the 2. You can see that with the domain. But if you look at the graph, your numbers can only be positive, up and down. Here, when I say vertical, here and here. Vertical. Vertical, up and down. And sorry to point out, this is your y-axis. This is, I forgot to point that out. This is your y-axis, this is your x-axis, y-axis. But the range is, that's your range. This is range. Just want to make sure I point that out. Range. Right here, looking up and down here. What are the values when I graph this? Well, your graph, here's your highest value here. Now I didn't go put all the numbers in, but I already know how to graph this. But if you go and graph this on a graphing calculator or whatever you want to graph it with, or by hand, you can see that the maximum on this is 2. So the highest this graph goes is 2. And the lowest it goes as far as horizontal, vertically, I keep saying vertical, horizontal, but vertically up and down is from 0 to 2. 0 to 2. 0 to 2. So your range in interval notation will be from 0 to 2. That is your range. So the whole point of this whole thing is really not to focus on the domain. Domain most people generally get, but it's the range. Range can be difficult at times if you don't graph it. You really, in some of these problems, every problem, every approach to problem is not the same. So to ensure that you got the right thing, you probably want to graph the graph to get the range so you can see what it looks like. And you'll know the range specified. It'll be right there in front of you, the answer. So this is the only thing I want to point out. I know this is not long, but I didn't intend it to be long, but I think it's something important that students struggle with as far as calculus is the domain and range, and mainly the range. So I hope this helps. I really do. Thank you.